Okay. Good evening, everyone. So today we are here for the second for the fourth week of our tutorial session on the course Petroleum Technology. So let me share my screen. Okay. So in this fourth session, we will be talking about the various properties and testings required for the various petroleum cuts. So basically, as I told, that crude oil consists of different products. Not it doesn't. It is not a single composition. It consists of different cuts, such as the diesel oil is there, then kerosene oil is there, then gasoline is there, then fuel oil is there, then lubricating oils are also there, then some other heavier cuts are also present in the crude oil. So the properties of these different cuts are different, and for testing them and for determining them, there are different methods which are employed in our data, in our, uh, I mean, are employed. So therefore, we will be talking about these different methods to determine the properties of these petroleum products. Okay. So the petroleum products cover a wide range of substances. So the properties that make them suitable for specific use differ from case to case, as I told that their application, depending on the application, different petroleum products are used in a different manner. Okay. So due to which no single set of test procedure is therefore available for evaluating them. And also depending on the country's specifications also, there are various testing methods and various uh, various testing methods, they differ. Okay. So coming on to the first property, which is the specific gravity, it basically gives us an idea about the density of our crude oil cut. Basically, as we can see that there are various crude oil cuts than in the crude oil. So for the specific gravity, in the case of specific gravity, suppose this is the cut A and this is the cut B. Suppose this is the cut B and this is cut A. This is suppose lighter cut and this is heavier cut. Heavier than this A, okay? Not very heavier, but after this A, this B cut comes. So the density of this A cut, if suppose it is 81, then it is not the density of this near portion of this A cut. Suppose this lower limit of A cut density is 81. So the density of the upper limit of this B, suppose it is 82 or it is suppose 82, 81.2. Okay. So by this we can see that here much difference in the specific gravity is not there. So it is very difficult to distinguish between two different cuts. So heavier specific gravity means higher concentration of basically specific gravity. Heavier specific gravity means the higher content of carbon in relation to hydrogen. So instead of so to easily distinguish between two different cuts, what is done instead of specific gravity to determine the density of a crude oil cut, API gravity is used to distinguish between two adjacent fractions in terms of their gravity. Okay. So API gravity, what is API gravity? It is basically it is basically this specific gravity 60 by 60 mean at 60 degree by 60 degree at 60 degree Fahrenheit by 60 degree Fahrenheit. minus 130.5, 131.5. It is basically that the crude oil specific gravity and water specific gravity both are taken at 60 degree Fahrenheit. So if we introduce the specific gravity value here, then in this formula, we can see as the specific gravity value is in the denominator, the API value gets magnified compared to specific gravity. As we can see here, there is not much difference, but if we put these two values in this API gravity formula, then the value of two API gravities will be quite far away, and thus that API gravity scale is way more magnified in comparison with the specific gravity. Thus, distinguishing between two adjacent fractions becomes easier. Okay, coming on to the second property, which is viscosity. It is an important property of a fluid. As we know, it is basically the measure of the resistance to flow. Means when basically the resistance which is applied to the flow of a crude oil or a petroleum cut, it is determined by the viscosity. The conventional method for oils it is to measure kinematic viscosity, and its unit is expressed in centistokes. Okay. And different standard viscometers are used for measuring the viscosity of the oil. It is basically what is done that the time for flow of a crude oil or a specific sample, crude oil sample, the time for its measurement from a standard orifice is measured. Suppose in this, these are different viscometers which are used. That is the angular viscometer, Redwood number one, Redwood number two, Sebolt universal, Sebolt Fural. So basically, the unit for this uh, angular viscometer, it is degree angular. Then here it is, and different all others, these viscometers, they have different units. So basically, what happens in the angular viscometer, that sample crude oil is allowed to pass from a definite from a standard orifice, and similarly water is also allowed to pass from the similar standard orifice, and the time difference between the flow of the both same amount of water and same amount of crude oil sample is measured, and the lapse that mean the time difference required for the flow of water and crude oil is measured, which is further expressed in terms of degree angular, and further it can be related by giving a viscosity value in the terms of centistokes. So viscosity is very important property for transportation fuels such as gasoline, diesel oil, for fuel oils used for burners and or lubricating oil. So basically, for in transportation fuels such as gasoline, etc., viscosity is very important because in a transportation fuel, it needs to be injected into the engine. So for injection of the fuel into the engine, viscosity is very important. If it is highly viscous, then it cannot be easily injected into the engine. So that becomes a problem. And for fuel oils and burners also, for fuel oils and burner needs to be atomized for it to light up in the burner. So in that case, also for atomization purpose, viscosity plays an important role. If it is highly viscous, then atomization of the fuel oil becomes very difficult. And then lubricating oils also, if it is highly viscous, then it will not be able to lubricate. It will not be able to enter into the closed parts of the working parts uh, working parts of the basically two moving parts of a machinery. And if it is if its viscosity is very less, then it may drip out of the it may easily drip out of the of the moving parts, thus defeating the whole idea of lubrication. Next property is viscosity index. It is basically the action of lubricating oil in a particular system, which the action of lubricating oil, it is basically a viscosity index is basically a property of lubricating oil. So the action of lubricating oil in a particular system, it depends on its viscosity. So viscosity temperature relationship, it is denoted by basically the viscosity index. It is a viscosity temperature relationship. Basically, the change in the viscosity with respect to temperature is expressed as viscosity index. So viscosity index is expressed in a scale from 0 to 100. So basically, if the viscosity index is very high, it means that if we increase the temperature, if there is a huge change in the temperature, then also the viscosity will not change. What happens is basically, if we have to, what happens is lubricating oils are used in between the moving parts of the machinery. So during that motion of the moving parts of the machinery, what happens is temperature increases, due to which the viscosity may change of the lubricating oil, and thus may create problem either by increasing or decreasing its viscosity. If thus, for being a good lubricating oil, what is required is, due to the change of the temperature, there should be a minor or no change in the viscosity is required. Therefore, if the viscosity is very high, then, if suppose it is a 0 to 100 scale, if the viscosity index is very high, then it is a very good lubricating oil. Okay. So viscosity gravity constant is another property of crude oil. This is the property of lubricating oil viscosity index, but this is a property of crude oil. Okay. This constant involves gravity as well as viscosity, and this is the formula for the viscosity gravity constant, which is 100 G minus 1.0752 log V minus 38 upon 110 minus log V minus 38, where G is the specific gravity at 60 degree Fahrenheit, and V is the viscosity at 100 degree Fahrenheit. Okay. Coming on to the distillation range. So basically, the distillation range of a petroleum distillate product is the characteristic of that product. Basically, this is the main characteristic of a. Just a second. Hello, am I audible? Hello, Surendran. Hello, hello. Am I audible? Hello. You can unmute your mic and say yes or no. Okay. Not willing to speak. Okay, so distillation range is basically distillation range of a petroleum distillate product is the characteristic of that product. So different products have different distillation ranges, and which actually differentiates them, and is a very important property of a specific petroleum cut. So this enters into the specification of distillation. This uh, Distillate products such as gasoline, kerosene, etc. In the distillation test for the petroleum product, a measured volume of oil is distilled in batch mode at the specified rate. Okay. The batch distillation curve is constructed by plotting volume percent distilled against the temperature at which the volume is distilled. Okay. So what happens is, we take a sample of crude oil, and it is distilled. It is distilled in a standard. It is distilled in a standard distillation unit. Basically, a batch distillation unit. What happens is, we take a sample crude oil, and when it is heated basically, and different distillation cuts are taken out. Depending on the temperature, and the volume percent of distilled is uh, this percentage distilled is plotted against temperature at which the volume is distilled. Okay, so basically we get a curve like this. So the initial boiling point and the final boiling point, initial boiling point and the final boiling point are recorded as a characteristic of the distillate cut. So basically, this is the distillation apparatus. This is the standard distillation apparatus. This is ASTM 386. What happens is, this is a RB. Here we take the sample crude oil. It is heated by this burner. From here, it is heated, and a thermometer is inserted in this beaker, in this flask. So what happens is, when it heats, vapors are formed. And here a limb is also attached along with this flask. It is basically this kind of RB with a limb here, okay? And the bulb of the thermometer is at the mouth of this limb. So what happens? The vapors, when they generate, this limb, it goes into this condenser bath. This is basically a condenser bath. This limb goes in here and directly it goes from here to here. Okay. So when the vapors are generated, this uh, these vapors go inside this limb, and some amount of this after going through in the condenser, it gets condensed. This vapor portion gets condensed, and some amount of vapors after coming in contact with the bulb of this thermometer, it gets condensed back and is given back into the flask as reflux. Just a second, this tip is not working. So what happens is the vapors from the limb goes into the condenser and gets condensed, which from here after condensing starts dripping into this tube. Okay, this collecting tube. So the temperature at which the first drop after condensing here falls is the initial boiling point. Okay, and this temperature is recorded in this thermometer. From this thermometer, we can see the initial boiling temperature, uh, initial boiling point, and after the whole this crude oil is evaporated, the temperature in the thermometer is measured, which is the final boiling point. Okay, and a graph of percentage volume distilled to temperature is plotted using this distillation apparatus. Coming on to the another property, which is the Reed vapor pressure, it is the measure of volatility of mostly gasoline distillate. So this Reed vapor pressure is mainly for the gasoline distillate. Why gasoline distillate? Because this is the lightest cut from our crude oil. Okay, so this is the lightest cut. So it is mainly, so therefore it has higher vapor pressure. So it is mainly the property of gasoline distillate. The amount of gaseous hydrocarbons or low boiling components dissolved in gasoline is a function of the degree of weathering of that oil or the pressure at which it is collected. So basically in our gasoline, sometimes there are lower cuts also available, which are present, which are due to the degree of weathering of that oil or due to the pressure. If it is collected at high pressure, then also some amount of lighter cuts may be present in the gasoline. So the what we do, we so these lighter cuts to further purify and uh, enhance our gasoline. Sometimes as we saw in the previous classes, steam stripping is done to remove these lighter cuts. So what is done? This is a standard machine for the Reed vapor pressure measurement. So what happens is this is a water bath where water is heated to a specific temperature, and this is a bomb. This is basically a RBP measurement instrument. With here, this is a steel bomb where our gasoline is stored, and this is a measuring meter for this is a meter for measurement of the vapor pressure. So the gasoline is stored in this bomb, steel bomb, and the water is heated up to a specific temperature. And after storing the gasoline in this bomb, this whole arrangement is kept into this water bath. And after this bomb, after attaining the temperature, after increase of the temperature of this bomb by the heat of this water, what happens is the lower cuts in this gasoline will evaporate and will settle in this vapor portion. This is the channel for or cylinder for the storage of the vapor which are generated from this gasoline. Okay. After this, all the lighter cuts get stored here, and then this instrument is taken out of this bath, and it is shaken vigorously shaken vigorously. Like this, we will shake. It is shaken vigorously, and what will happen is after that, why this is done to ensure the complete removal of the these lighter cuts from our gasoline, and after that all the lighter cuts will be stored here in the upper channel, and the reading in this meter will be giving us our read vapor pressures. Okay, so the true vapor pressure is higher than the read vapor pressure. Okay, by 5 to 9%. The read vapor pressure of a mixture is determined experimentally according to a procedure standard by the American Society for Testing and Materials, and at 100 degree Fahrenheit to 37.8 degrees C. So this water, it is heated up to 100 degree Fahrenheit or 37.8 degrees C. Okay. Coming on to our next property, which is flash point and fire point. So, what is flash point? It is basically the minimum temperature at which the given oil evolves the sufficient amount of vapor to form inflammable mixtures with air, as shown by the formation of a momentary flash when external source of fire is brought in contact with the vapor. So, this is basically the able apparatus for the measurement of flash point. So, what happens is we take our crude oil sample into this able apparatus, inside this able apparatus, and it is heated slowly, and then which generates vapor of that crude oil inside this apparatus, inside this bomb, and then a external fire source, suppose external matchstick source, is inserted from this second channel, which will what it will do, as the temperature increases and the vapor starts to generate of the crude oil, there comes a temperature at which this these vapor in coming when coming in contact with this external fire source, it will give a momentary flash. Okay, that is basically the mean the threshold, basically the starting point of the fire risk. Basically, at this temperature, after this temperature, the fuel oil should not come in contact with a fire source, otherwise fire will be caused. Okay, so this is basically the it is basically the measure of fire risk of an oil. Mean after this temperature, the fuel becomes hazardous. It can catch fire easily. Okay. So the fire point, it is basically the minimum temperature at which the oil vapor will continue to burn instead of just flashing. Instead of just flashing, it will continue to burn. Basically, the fire point is, and this is obvious that this fire point is higher than the flash point. Okay, so fire flash point is much important than fire point, because at flash point we get the idea that no, we cannot handle this crude oil sample after this temperature, otherwise it will cause fire. Okay, so different instruments, different apparatus are used to determine flash point and fire point. So this instrument, Pensky Martin instrument, it is used for the measurement of flash point if it is greater than 50 degrees C, basically for uh, just a second, higher boiling crude oils, greater than 50 point, basically higher boiling crude oil such as fuel oil or diesel oil. Okay, and able apparatus for less than flash point, where flash point is less than 50 degrees C, basically the low boiling crude oil samples, which is gasoline, LPG, etc. Okay, and Cleveland open cut apparatus for heavy residues, very heavy residues such as lubricating oils, etc. So this open cup apparatus and these both are the closed cup apparatus. So this open cup apparatus gives a, it does not give mean this closed cup apparatus gives much accurate, much better mean calculation, much better reading for flash point, much accurate reading compared to the open cup apparatus. Okay. Coming on to the next property, which is pour point and cloud point. Pour point and cloud point are the criteria used for fuel oils and lubricating oils and diesel oils in cold surroundings. So basically, this pour point and cloud point, they are basically measured for fuel oils, lubricating oils, and diesel oils when they are transported from a hotter area to a colder area. Why so? Because what is this pour point? It is basically the temperature which is 5 degree Fahrenheit or 2.8 degrees C higher than at which the oil ceases to flow when cooled and tested according to prescribed conditions. So what happens is, this is a 4-point apparatus. A fuel oil, fuel oil or a crude oil sample is taken into this apparatus, into a vessel, and it is kept into this apparatus where the temperature decreases gradually, and there will be a point when you will see that the crude oil has completely ceased to flow. Okay, so what happens is when the temperature at which it completely ceases to flow, oh, we will add, suppose our crude oil ceases to flow at 2 degrees C, so we will add 2.8 degrees C into it, which will give 4.8 degrees C, so which is its 4 point. So basically we are telling the low 4 point is basically a requirement for a good oil in respect of handling in cold environment. So basically it is that when we transport a fuel oil or crude oil from a hotter area to colder area, what will happen due to decrease in the temperature? The viscosity will increase, and moreover, due to the formation of crystals of wax crystals into the crude oil, what will happen is the freezing of the liquid will take place inside the pipeline, which is not desirable. Therefore, a lower pour point says a lower pour point means that the crude oil will freeze at a much lower temperature, therefore, a lower pour point is our desirable property. Okay. Cloud point is defined as the temperature at which the oil becomes cloudy when it is cooled in a specific manner. So before freezing, what will happen? In initially, it is not like that you decrease the temperature and at once it will freeze. It will start becoming hazy. At first, it will start becoming hazy. A small blurriness or the haziness will start to occur in our clear, transparent crude oil. That is the point which is called the cloud point. So it gives us a basically it is an indication that our core point is about to reach. Okay, so we need to get our core point below or much lower than this. Okay, so this temperature is basically higher than the pour point. Okay. Sometimes what we do, the pour point depressants are also used to improve the quality of our crude oil. So basically the asphaltic substances, they are used as the pour point depressants. Why depressants? Because we need to decrease the temperature. We need to decrease the pour point so that our crude oil can still work at much lower environments. It can still flow at much lower temperatures. Okay. Coming on to the freezing point, it is defined into two manners. Suppose if we take a uh, freezing point is basically the temperature at which the crystals of hydrocarbons formed on cooling disappear. If suppose we take a frozen crude oil sample and we start to heat it, there will be a temperature when it completely the crystals formed inside the crude oil, they completely disappear. So that is basically the freezing point. And another one is if we take a sample of a crude oil and start to decrease its temperature, is we start to cool it, then what will happen? The oil has to at one temperature, the oil will lose its ability to flow. Oh, and it will freeze. That is the freezing point. Basically, the starting of the formation of the first crystal, first freezing crystal of the insider crude oil, it gives us the freezing point. Okay. Congealing point, it is basically the property of petroleum wax. Only for petroleum wax, it is determined by applying what is done. We apply a drop of molten wax, petroleum wax, onto the bulb of the thermometer, and then it is stirred. Then it is stirred into it is stirred into a standardized cooling condition. Basically, it is rotated into a standardized cooling condition, and the temperature at which the congealing of this petroleum wax takes place, basically the freezing of this petroleum wax takes place, it is the congealing point and it is suitable. This test is suitable for all kinds of waxes. Okay. Coming on to the next property, which is the smoke point and char value. So this is the empirical criteria are determined to assess the burning quality of kerosene. This is a property of kerosene oil. Okay, as a illuminant or a fuel. Okay, so the smoke tendency. What happens is this is the smoke point apparatus. Here we take the kerosene sample, and here a wick is there. A standard wick is there. which needs to be burned using this kerosene. So when this wick is burned, what happens is it starts to burn, and if we increase the wick, if we increase the length of the wick using I mean there is a device for increasing the length of the wick. What will happen? The flame will start to increase its length, and at a point you will see that there will be the flame will be at a height where it will start forming smoke. So it will start to come out from the tip of the flame. And if we again decrease the height of the wick, then there will be this point when this smoke had just stopped coming and the smooth round flame will be there. So this is the point at which this soot or this smoke starts to form on the tip of our uh, flame. Okay, so this is the flame height at which the smoke has just started to come. So it is the maximum smoke point is the maximum flame height in millimeters to which a kerosene will burn without smoking in a standardized apparatus. So just when the smokes, if we are decreasing the length of the wick, and obviously the length of the flame will also decrease, there will be this point just the start exact point when this smoke or the soot from the tip of the flame will just stop coming. So that height of the flame will be taken as the smoke point. It is measured in the flame height in millimeters. Okay. Good quality kerosene shows smoke point of about 20 to 25 mm. Okay. The smoking tendency of kerosene is determined by the smoke point test and the deposit forming on the tendency and the deposits form. And there is some after the burning of the wick, after the burning of this kerosene, for a specific time, what will happen? There will be the formation. There will be some formation on the tip of the wick, which is given as the char value, and it is measured by the char value test. Okay. The char value is the amount of char in milligrams for every kilogram of kerosene burned. Okay. Milligram of char per kilogram of kerosene burned on the wick of a standard lamp burning under prescribed condition. The char value of a high grade kerosene should not exceed 20 mg per kg. And the formation, what will happen? Kerosene will be here in this chamber. Wick is there. Suppose we take a specific amount of kerosene is taken, it is allowed to burn for 24 hours. And after 24 hours, the amount remaining in the kerosene lamp, the remaining amount of the kerosene is measured and the wick is taken out, and on the tip of the wick you will be see there is some deposit. This deposit is taken out in a watch glass and it is measured, and the char value is given in terms of mg of this char upon the kg of kerosene burned. Okay. And also there is some formation, there is this some blurriness on the walls of the lamp. The formation of smoke and char depends on the type of burning appliance. This formation may be due to the presence of some in this sulfur content in our kerosene, which gives this there is this haziness on the glass of this lamp. Okay, smoke point should be high, whereas the char value should be low for a good kerosene. Okay. Now coming on to the carbon residue. So basically, as we know, these all these cuts are basically hydrocarbons. So hydrocarbons are just they consist of carbon and hydrogen. So after burning, when we burn this crude oil, what will happen after complete burning of this crude oil? What will happen? Cracking will take place and oxidation will take place. Yes, and after that, the left amount will be that will when oil is heated, basically on decomposition, complex compounds form some carbonaceous deposits which are called the carbon residue. Okay. So there are two methods for determination of the carbon residue, which is the Conradson method and Ramsbottom method. Conradson method is used for the fuel oils and Ramsbottom is used for the lubricating oils. Okay. So this Conradson method, this is the Conradson carbon residue test. Here we will take our crude oil in a crucible. In this crucible, our crude oil sample will be taken, and it will be kept in here, and here burner will start burning And after some time, after complete burning of this crude oil, we will take out this crucible and we will see some amount of carbon residue will be left in between, in below, mean stuck on the walls of this crucible, on this that vessel, which will be scraped off and measured to get our carbon, the amount of carbon residue that our that our fuel oil gives. Okay. So coming on to the Ram's bottom carbon residue test, this sample after being weighed into a specific glass bulb. This is a specific glass bulb in which there is this capillary and our heavy lubricating oil. It is a specific amount of lubricating oil. It is inserted from this capillary into this capsule. Full capillary opening is placed in a metal furnace maintained at, and it there are numerous carbon capsules. Many carbon capsules are there, like 4 to 5 carbon capsules. They are kept in this stand, and they are then kept inside this metal furnace, which is maintained at 550 degrees C. And the sample is thus quickly heated to point at which all the volatile matter is evaporated out of the bulb. At it is heated to 550 degrees C, then all the volatile matter inside the bulb is evaporated, and after a specified heating period, the bulb is removed from the furnace, cooled in a desiccator, and weighed again. After cooling, these bulbs are weighed again, and the residue remaining is calculated as a percentage of original sample. Okay. So the amount of residue which will be remaining inside these capsules, an average of all these 4 or 5 capsules is taken, and it is given as it is calculated as a percentage of the original sample, which was firstly loaded, original lube oil sample, which was firstly loaded in these capsules. Okay. Coming to the property, that is the gum content of the gasoline. During storage, some classes of hydrocarbons, that is in gasoline blends, particularly they consist of olefins and diolefins. So what happens is, as I told in the last sessions also, with gasoline it is stored in open floating head storage tanks. Okay. So what happens is, suppose this is a tank, the lid of this tank, it is not completely closed. There is some portion which is open to the atmosphere. Why so? Gasoline is stored in here. Gasoline, as I told, it is light cut. It is lighter cut. So there are some generation of lighter cuts also. Some vapors are there. So these vapors can escape to the environment without causing any pressure in this gasoline tank, moreover causing any hazard due to these lighter cuts. So some amount of space is given off so that these lighter vapors can escape. Moreover, as we can see, there is this opening, so we can say that this gasoline is some amount of gasoline is in contact with the aerial oxygen. So what will happen? This aerial oxygen will react with the olefins and diolefinic components present in the gasoline, ambient temperature, and the formation of oxidation products, and it forms a resinous. These olefins and diolefins are basically double bond hydrocarbons. So, as I told in the previous class, these double bond hydrocarbons, they may form polymers. Okay, long chain polymers may form. So the oxidation of these products, these components inside the gasoline, they form oxidation products which are resinous and polymer solids, basically commonly called deposits or gums. Okay, so these gums sticks to the metal surface along the vehicle. These gums may stick to the surface, the storage surface, or it may, when formed in a huge amount, it settles down as sediment from the uh, okay. So the accumulation of these products can cause engine wear and can also have adverse effect on engine efficiency, performance, and emission and durability. So gasoline also loses, as I told you, that these components oxidize to form these resinous gums. So we can say that it loses these important components that are olefins and diolefins, which are also which also act as octane enhancers. So what happens is it increases the gasoline density, boiling range also increases, aromaticity rises, and olefinicidity decreases. Okay. Thus, overall, we can see that it reduces the quality of the gasoline. These are some of the important terms related to gum. Existence gum, it is basically if a chamber, if a storage tank consists of some amount of gum, then after the evaporation of the aviation, after evaporation residue of the aviation fuel, mean if all the fuel is taken off from the tank, uh, okay, without any further treatment, the amount of gum which is left in the tank, it is the existent gum. Then this existent gum, it is dissolved in a solvent, in a suitable solvent. Then the amount of solvent which dissolves in the amount of gum which dissolves in the solvent, it is called the soluble gum, and which remains without dissolving, it is called the insoluble gum. And the potential gum, it is basically the sum of the soluble and insoluble gum. Okay, the sum of both these gums, it is the potential gum. It is basically the potential of a gasoline cut to produce gum. Mean basically the maximum amount of gum which can be produced out of a gasoline cut. Okay, it is basically the existed gum is basically what amount we got, but obviously, it is not possible that all amount of olefins and diolefins they have oxidized and converted to and formed gum. Some amount may have been left, but all that left amount of olefins and diolefins also have the potential to oxidize and convert into gum. So all that gum, if we include together, that is the potential gum. Okay. This is basically a small flow chart telling about the overall fuel stability. A fuel consists of different components: paraffins, naphthalene, aromatics, olefins, then heteroatoms such as sulfur, nitrogen, then compounds such as metals also are present. Some amount of metals are also present. Okay. When oxidation, they form hydrogen hydroperoxide. These are the active species which forms gums. Some soluble oxidized products and some insoluble oxidized products are formed, which acts as the main precursor. Basically, they act as precursor, or which upon nucleation or agglomeration, will suppose a small amount of gum is formed. This act as precursor. It acts as the nucleation point, and further more amount of gum starts to form upon it. Okay. If it is stored for a long time, then this gum it starts to settle down as sediment. And if this fuel is taken in for some thermal condition, suppose it is used in vehicles, then it is injected into the engine. And if it is used for as fuel oil in burners, then atomization is required. In all those cases, this gum will it will create problem, and it may cause corrosion of the engine or burner, and it decreases the efficiency of our gasoline cut. Okay, coming on to the gum content testing apparatus. Here, uh, vessels are taken in which gasoline is taken. These vessels are put inside these chambers. Okay, and these are basically pipes which are through which hot oxygen will pass. So these pipes are after putting these gasoline samples inside these grooves. So these pipes are kept over this. Over the opening of these opening over these openings, and hot air will be passed through these pipes into this gasoline sample. And after the burning of this whole, after the after some for a specific time, this hot oxygen will be passed into the gasoline sample. And after some times, we will see that in the presence of the oxygen, this hot oxygen, oxidation inside the gasoline takes place, where olefins and diolefins they oxidize and form the gum. And that gum will be it will stick on the vessel or settle down into the vessel of the gasoline. And after the test, all these vessels are taken out by the tongs, and the amount of gasoline is measured. An average of the amount of gasoline is measured with respect to the average of the amount of gum formed is measured with respect to the gasoline taken. Okay. Coming on to the sulfur content, another property which is the sulfur content. Sulfur, as I know, as I told you, that sulfur remains in different forms of compounds in crude oils as well as the distillate cuts. So as the different cuts are given out, the smaller mean there is less amount of sulfur present in the lighter cuts, whereas the high amount of sulfur or the larger molecular weight compounds of sulfur are present in the heavier cuts. Okay, so basically sulfides, disulfides, sulfides are present, disulfides are present, then mercaptans, thiophenes, and its higher molecular weight derivatives can be found in the crude oil. Lighter cuts contain lighter sulfur compounds, whereas the boiling point of the cuts increases, the heavier sulfur compounds are found in them. So basically, in heavier cuts such as lube oils and then asphaltenes and fuel oils, much more sulfur content is present in compared to the gasoline, kerosene, etc. Okay. On combustion of the fuel, these sulfur compounds form objectionable sulfur dioxide gas which pollutes the environment. So, laboratory determination of the sulfur content in the fuel is best done by using bomb method. Okay, so when this combustion of this fuel takes place containing some sulfur compound, they form objectionable sulfur dioxide gas when effluated out into the environment, it pollutes the environment. Okay, so in the laboratory, determination is done. Okay, self. So the determination of sulfur content in polymer oil and petroleum oil by can be done by bomb method. This this test method covers the determination of sulfur and petroleum products sufficiently low in volatility and containing at least it can determine the amount of sulfur present in petroleum oils which are low in volatility, and it may contain at least 0.1% of sulfur. Okay, the sample is what is done. Sample is taken here. Okay, and it is heated. The sample is oxidized by combustion in a bomb calorimeter. Uh, okay, this sample is taken here in a bomb. This is the bomb, and oxygen is passed through a channel. Okay, is combusted in a bomb containing oxygen under pressure. Oxygen is high pressurized, high pressure oxygen is passed into this bomb by using a compressor, air compressor, or any other method. The sulfur as sulfate in the bomb washing. What will happen after heating it for some time? What will happen? The sulfur in the after heating heating of this crude oil sample in presence of oxygen, it will form sulfur dioxide. Okay, SO2 will be formed. The sulfur, further, this bomb will be taken out. Okay, it will be taken out, opened, and the amount of SO2 it will be the SO2 which is formed, it comes out and mixes into the water. And moreover, this bomb will be washed several times so with water, and that water will be taken as will be collected along with this water. So the sulfur as sulfate in the bomb washing is determined gravity. What will happen when this washing of this water is collected and it is treated with BaCl2? What will happen? This BaCl2 in the presence of sulfate will form BaSO4, which is barium sulfate. It will be collected as barium sulfate, and the weight will be measured, and back after the back calculation we can determine that what amount of sulfur was present in our crude oil. Okay, a bomb having a capacity of not less than 300 ml made of stainless steel which will not be affected by the combustion process or product is taken here. Okay, so sample cup and firing metals, they are firing wire are made of platinum. Okay. So basically, what happens is this is the bomb which is taken here. Here we will this is the bomb and this is for closing the lid and this will be kept above here. Okay, and after that this will be kept in here and this will be used for closing this here. Okay, this for locking in this and this together. So what will happen? We will take our sample, crude oil sample here. Two electrodes will be introduced in from this portion, and this is the pinch cock for introducing the oxygen. Okay, a platinum wire will be tied here, and a cotton thread will be tied onto this platinum wire, and it will be introduced, dipped into this crude oil, so that the whole cotton wire will be wet with the crude oil sample. When the electricity is introduced using the electrodes and it passes through this platinum wire, a spark is generated and this cotton wire catches fire. And in the presence of this fire itself, the crude oil burns, burning out the sulfur content. Okay, the ignition circuit capable of supplying sufficient current to ignite the cotton wick or nylon thread without melting the wire. Okay, coming on to the next method, which is the wick mold method. Total sulfur content of a volatile petroleum that bomb method was for non-volatile petroleum products, but this wick mold method is for volatile petroleum product is measured by lamp method or wick mold method. Sulfur in the sample is oxidized by combustion and is estimated volumetrically after absorption in the sulfur that comes out after burning of the after burning of a bomb is taken after a lamp is taken where the volatile petroleum product is heated, it is burnt and it is this sample is oxidized by combustion, and after that the sulfur dioxide given out by this Wick-Bowl test upon oxidation, it is absorbed into the hydrogen peroxide, and this method may be applied to products having sulfur content in the range of 1 to 10,000 mg per kilogram and is particularly suitable for distillates with total sulfur content less than 300 mg per kg. Okay. The method can be used for determination of volatile sulfur in substances supplied to the burner in the gaseous state after vaporization from the liquid phase. So, as I told, this is basically for the determination of the volatile sulfur. If there are some in the petroleum cut, there is the presence of volatile sulfur. So, it will be oxidized. The sample will be oxidized by combustion, and that volatile sulfur will be given out and it will be absorbed in hydrogen peroxide, and after that the measurement of the after the using the back calculation we can hydrogen it will absorb in the hydrogen peroxide forming the sulfuric acid, and this sulfuric acid will be titrated with NaOH to determine the amount of sulfur present in our sample. Okay, it is not suitable for the determination of sulfur in heavy duty engine oils. Okay, coming on to another method, which is the doctor's test. It is basically a test done for the sweetening of our sour fruit samples. Basically, the mercaptans and hydrogen sulfides have objectionable odors and are said to make our oil sour. So basically, as I told in the earlier classes, the sour crude oil, it basically consists of mainly, we are basically talking about the H2S and mercaptans. Okay. Only if H2S and mercaptans are present in a crude oil sample, then it will foul smell, and we need to make that sample convert these mercaptans or H2S into either sweet smelling products, or we need to remove these mercaptans and hydrogen sulfide from the crude oil. Okay. Basically, a stock is sweet if it passes the doctor's test. If it passes this doctor's test, then this stock is sweet. It does not consist of any foul smell. Okay. This process converts the mercaptans and hydrogen disulfides and almost elemental sulfur into oil-soluble sulfur compounds, but does not materially remove sulfur from oil. So in this, doctor says what we do not remove this sulfur content, but we convert these hydrogen sulfide, mercaptans, and elemental sulfurs into some oil-soluble sulfur compounds, which are not removed from the oil, but it dissolves into the oil. But the foul smell due to the H2S and mercaptans is reduced, and it gives a sweet smell. The oil sample is shaken with an equal amount of sodium plumbite solution and a small amount of sulfur. So the oil sample, crude oil, it is here is the reaction. The crude oil containing mercaptans, it is shaken with this sodium plumbite, which gives lead plumbite and NaOH. And this lead plumbite, as I told, as it is shown here, it is shaken with the equal volume of sodium plumbite and small amount of sulfur. So why sulfur is taken? Further, this lead plumbite, it reacts with the equal amount of sulfur to give disulfide and lead plumbite, okay, which is basically a black precipitate. So this disulfide, it is soluble in oil, okay. So the mercaptans first react with the sodium plumbite to form oil-soluble lead mercaptide. So this lead mercaptide formed here, it is oil-soluble. Okay. The mercaptides on further reaction with the elemental sulfur form sweet-smelling oil-soluble disulfides and give a black precipitate of lead sulfide. Okay. So what happens is if we have a crude oil sample and we put it in a test tube along with sodium plumbite, and it forms there, if it forms a black coloration, I mean black coloration, if there is some dark coloration, if it does not occur, the dark coloration does not occur, then we can say that our crude oil is sweet. Okay, why so? Because suppose if in a test tube we take crude oil and sodium plumbite, then it will form black colored PPT of lead sulfide, which will form on the interface. So if there is no black coloration or dark coloration, then we can say that there is no presence of mercaptans. Okay. So if there is no presence of mercaptans, we can say that our crude oil is sweet. Okay. So the process by which foul-smelling stocks are rendered sweet-smelling or odorless, this is called the sweetening process. This process is called the sweetening process, but the test is called the Doppler test. Okay. There are other methods for sweetening also, but this Doppler's test is one of the tests for sweetening process. Okay. Coming on to one of the most important characteristic or properties of gasoline. Basically, it is octane number. So gasoline It is used in a gasoline is used in an internal combustion engines, which is a spark ignition engine with reciprocating pistons. So the what happens is this fuel or gasoline is injected into the cylinder, and when it is injected into the cylinder along with air, it forms a mixture with air. It gets burnt by a spark generated by a spark plug. When it forms a mixture, this crude gasoline forms a mixture with air or oxygen. It is burned by a spark generated by a spark plug. So what happens is this chemical energy of the fuel is converted into the mechanical energy for giving a so here in this engine, this chemical energy is converted into mechanical energy as which is given off as shaft work. Okay. So the maximum power is derived from the gasoline, and after the burning, maximum power which we can get from a gasoline is when it burns silently and relatively slowly in an automobile engine. Basically, if it burns in continuous batches and slowly and gradually, then we can extract the maximum power from the gasoline. But under some conditions, what happen is the combustion may begin. Firstly, the combustion may begin smoothly, but what happens then after some time, the whole left out unburned fuel, it starts to burn rapidly with the formation of pressure waves, which is called the detonation. and this leads to the knocking of the gasoline engine. Okay, so these pressure waves they starts to generate. Mean after sometimes, firstly the gasoline burns smoothly, but after sometimes the whole remaining unburned fuel it burns with a uh, it burns rapidly with the formation of pressure waves, which is called detonation. And with these pressure waves, they create a huge thrust onto the engine, on the walls of the cylinder, due to which the knocking of the engine takes place. So much of the generated power it is wasted, and the engine life is shortened due to this knocking. Okay. A good gasoline should resist knocking. It should mean anti-knocking property of the gasoline should be good. So the anti-knock property quality of a fuel is measured in a standard engine. The anti-knock quality of a fuel is measured. It is measured in a standard engine in terms of the relative performance of the two standard fuels, then expressed as its octane number. So, how the octane number of a sample fuel is measured, we will be talking about. It is measured in a standard engine. A standard engine is taken where a mixture the octane number of gasoline is equal to the percentage by volume. Mean the mixture of isooctane and heptane is made in different volume ratios. Okay. This isooctane has an octane number of 100 and it has an octane, and heptane has an octane number of 0. So for the measurement of the octane number of a sample crude oil, what happens is we make different solutions of isooctane and heptane in different volume ratios. Suppose 40% or 40 percent of isooctane, 60% of N-heptane, then 50-50, then 90-10. Okay. So suppose these three solutions are made A, B, C. Suppose we can make many more solutions. Then the that ignition quality of a sample crude oil is measured, and the ignition quality of these ABC samples are these ABC solutions are also measured, and comparison of our crude oil sample along with these three samples is done, and and our sample it matches with what whichever sample ignition quality of our sample matches with whichever ignition quality of whichever of these samples. The volume ratio of that sample, volume ratio of isooctane in that sample is taken as isooctane. Suppose our crude oil sample matches with the ignition quality of this C solution. So in this solution, 19 volume percent of the isooctane is taken. So the isooctane of our sample is 90. Okay. And heptane is of poor anti-knock quality and is assigned 0 octane number, whereas isooctane has excellent anti-knock property and is assigned as octane number 100. Aromatics has the best anti-knock quality, and isoparaffins, naphthenes, and paraffins follow in succession. Okay. Certain additives are also added to the gasoline to raise its octane number. The most sometimes some additives are also added to the to our gasoline to improve its octane number. So commonly used additives are the tetraethyl lead and trimethyl lead, then methyl pentadienyl manganese tricarbonate. Okay. Um, Explanation of engine knocking. So, octane number affects the activation energy of fuel. An increase in octane number makes the fuel require high amount of energy before it starts to combust. Okay. Prolonged occurrence of engine knocking can cause serious damage to the engine inner parts. This is basically normal combustion when the fuel comes in. Fuel forms a mixture with the air. It start and this piston is pulling compress pulling the when good mixture of gasoline and air it comes in injected into the yes, when it is injected into the piston cylinder of the when it is injected into the cylinder of the engine, and it is and then spark is generated using the spark plug. This is the spark plug. If it burns in normal condition, then it burns like this. But after sometimes when complete combustion or rapid combustion of the remaining amount of gasoline starts, localized combustion of the these localized combustion, localized burning of the gasoline inside the cylinder takes place, due to which the inner linings of the due to which the knocking takes place and the inner lining of the engine gets damaged, which further decreases the lifetime of the engine. Okay. The most common type of octane rating worldwide is there are another thing is there are two types of octane numbers: research octane number and motor octane number. Research octane number is determined by running the fuel through a specific test engine with a variable combustion ratio under controlled condition, and comparing these results with those for the mixture of isooctane and heptane. Whereas the motor octane number, it is a better measure of how the fuel behaves when loaded, under load. Okay. This basically research octane number is, as I told, it is done in a standard engine. Uh, in a standard engine, our sample is tested. Along with that, some of the standard samples of a mixture of isooctane and heptane are tested, and then the comparison of our sample crude oil with the mixtures of isooctane and heptane is compared, and the volume percent of octane, isooctane present in the sample gives us the octane number. Whereas the motor octane number, it gives us it is a better measure of how the fuel behaves when under load. Okay. Depending on the composition of the fuel, the motor octane number of a modern gasoline is about 8 to 10 points lower than that of the research octane number. Okay. It is possible for a fuel to have a research octane number greater than 100. Yes, it is possible for a fuel to have a research octane number greater than 100, because isooctane, it is not the most knock resistant substance available. It is not like it is the most knock resistant substance. Thus, for substances with higher shock resistance, and the octane performance is an extrapolation of the octane performance chart. Okay. So some sources mention, so for those cases when the octane number is greater than 100, it is called the performance number. Sometimes it is called the performance number. The performance number is used to estimate knocking characteristics of aviation gasoline of octane number higher than 100. So basically, performance number is used in the case of aviation turbine fuel where octane number is greater than 100. The standard reference fuel for knock ratings above 100 are isooctane and its blends with triethyl lead. So basically, what we can say is that the isooctane, it is, we cannot say it is the most knock resistance substance available. So for the performance number, as we can say that the octane number is higher than 100. So what is the reference for such cases? In the cases less than 100, we can take isooctanes. But in the cases when the octane number is more than 100, what standard we need to take? It is the mixture, it is a blend of isooctane with tetraethyl lead. What is why tetraethyl lead? As I told in the last slide, that tetraethyl lead, it is an octane enhancer. The minor presence of lead, even minor presence of lead in the gasoline may enhance the of the octane number of the fuel of our gasoline. Why so? Because when tetraethyl lead is present, this lead, it oxidizes with the it initially it forms radical. This tetraethyl lead, on introduction with the gasoline, it forms instantly, it forms free radicals, which again forms free radicals with the gasoline as well as the oxygen present in the engine, thus preventing it preventing oxygen and fuel to instantly rapidly react with each other and combust. Okay, so which therefore it I mean it helps in the it resists in the knocking of the engine. Okay, these are the performance number of some of the fuels according to the specifications of the BS6 specification, that is the Bharat Stage 6 specification. The octane rating of normal petrol is 91. Okay, so right now the normal petrol, it has an octane number of 91. Coming on to the next property, which is the calorific value. It is the quantity of heat which is released per unit quantity of fuel when it is burned completely with oxygen and the product of combustion is returned to ambient temperature. So basically, it is the quantity of heat which is required for the combustion of a fuel along with complete combustion of the fuel in the presence of oxygen, and after the combustion the product of the left with the combustion left after the combustion, it is returned back to the ambient temperature. So the total amount of heat taken in this whole procedure, it is given by the calorific value. So there are two types of calorific value: gross calorific value and net calorific value. They are the higher and lower calorific value. Why so? Because the gross calorific value, it is the heat liberated by burning a definite quantity of fuel at constant volume in oxygen saturated with water vapor. Okay. The oxygen which is saturated with water vapor and the original material and the final products of combustion are at reference temperature of 25 degrees C, and the water produced by burning the fuel is in a liquid state. Okay. So the net calorific value at constant volume is the same. This is the gross calorific value, but what is the difference in net calorific value? It is also same, except the water produced due to the burning of fuel, it is in the vapor state. Here it is in the liquid state, here it is in the vapor state. Okay. Therefore, the gross calorific value is higher. As we can see here, it is this gross calorific value is higher compared to the net calorific value. Why so? Because also it is the amount of heat that is released during the condensation of water vapor is also added in the gross calorific value, whereas it is not present in the net calorific value. Okay. Therefore, this gross calorific value is called the higher calorific value and it is called the lower calorific value. Coming on to another property, which is the induction period of gasoline. So it is basically the test for the oxidation stability of gasoline. As we know that gasoline in the presence of oxygen, uh, uh, it forms gums. So therefore, which actually reduces its stability. It removes different important cuts from the gasoline. Therefore, this test is required for determination of the oxidation stability of gasoline under accelerated oxidation condition. Higher the induction period, better is the storage stability. For storing of the gasoline for a longer time, it should have a good induction period. Okay. So what happens is this is the gasoline stability tester. In this machine, gasoline is taken and it is heated, and oxygen is introduced into this along with the gasoline. High pressure oxygen at 6 bar and 100 degrees C is introduced into the gasoline chamber and gasoline chamber, and we will see the increase in the pressure when the oxygen is present, hot oxygen is present with the gasoline in this bomb. Then the pressure will start to increase, and after at a certain time you will see there will be the pressure will shoot up instantly. So this shoot up pressure will give us the time. That time up to which this pressure shoots up is taken as the induction period. So basically, an induction period of 360 minutes under laboratory condition can ensure the storage stability of gasoline of at least 6 months. Okay. Another test is the water separometer index. So basically, it measures the water separation characteristics of fuels. So water separometer index, it is a measure of fuel cleanliness related to its freedom from surfactant materials. Okay. So as we know that there is some amount of presence of water in the fuel, though water is not soluble in fuel, but still some amount of water is present in the fuel, which is basically, as we know that water is not soluble in crude oil, so it is present in the emulsion form. So this test is used to rate the ability of the aviation turbine fluid to release entrained or emulsified water when passed through a fiberglass coalescing material. Okay, so if we pass this aviation turbine fluid from this fiberglass coalescing material, and if then this emulsified water it coalesces easily, then we can say Okay. And if it coalesces easily, then it has a good water saporometer index. A higher water saporometer index indicates that the fuel is cleaner relative to surfactant materials. Okay, even the present, if higher water saporometer index is there of a fuel, then even the presence of those water molecules with the surfactant material, well, it does not affect the quality of the fuel. Okay. Coming on to lead in gasoline, as I told that lead is used in for the as an octane enhancer. It is the most used octane enhancer. It is an anti-knock agent, but still we know that lead is highly toxic. It interferes with the anti-pollution devices. As we know that when lead is in as gasoline burns, suppose any crude oil, if it is burned and it consists of sulfur components, so during the release of after burning of the crude oil, after releasing this effluent, this effluent consists of sulfur dioxide and other different components consisting of sulfur. So if lead is present, then these these effluents releases sulfur, but to reduce the air pollution, what is done that some amount of catalytic separators are present in the chimney. So if lead is present along with the sulfur, this lead will deactivate those catalysts, and further what will happen? It interferes with the anti-pollution devices, and the lead poisoning of the catalyst will be done. So when this catalyst is deactivated, there will be no separation of the sulfur the dioxide from the effluent gases, and sulfur dioxide will be released into the environment. Therefore, it says that it interferes with the anti-pollution devices. Lead is still used in aviation gasoline for some piston engine, propeller, aircraft. However, efforts are being made to lower and remove lead in this fuel as well. Okay. One of the main international standard test method for the measurement of lead in gasoline by using for the presence of lead in the gasoline, it can be done by the X-ray spectroscopy or XRF, that is the X-ray fluorescence. This test method covers the determination of the total lead content of gasoline within the concentration range of 0.01 to zero point 0.1 gram of lead per US gallon, that is 22.5 milligram per liter to 25 milligram per liter. Okay. Coming on to another property, which is color, it is an indication of the degree of refining of the product. So mainly the crude oil, it is of different colors. So lighter cuts, they are mainly transparent or yellowish in color, and heavier cuts, they consist of some amount of deep coloration. Okay, so various test methods used for the measurement of colors of petroleum product along with the main equipment and proper product application is given here. So these are some of the equipment, that is the Sebold chromometer, ASTM color, or the color of dyed aviation gasoline, and color of the Lovi-Bolt tintometer, Lovi-Bond tintometer. All these instruments, these equipments are used for the for measurement of the color on a color scale for different kind of petroleum products. Okay. Coming on to another property, which is the ash content. The amount of ash in petroleum product is normally very low. Okay. It is normally in residual fuels, it has an ash content of 0.1% ash content in residual fuels, which are heavy fuels. So only this amount of ash content is present in heavy residues. So we can this tells simply that in the lighter cut there is no amount of ash present. So distillates should have zero ash content. But sometimes what happens is we add some kind of additives to gasoline, diesel fuel, which upon burning upon burning leaves some amount of ash. Okay. A known amount of sample is ignited and the carbonaceous residue left is heated. This carbonaceous residue is heated into at a temperature of 800 degrees C in a muffle furnace, cooled and weighed as ash. Okay. Refractive index, if the crude oil it is lighter in color, then we can measure the refractive index. But most of the if our crude oil it is the heavier residues they have some coloration, so it is very difficult for the heavy dark colored crude oil for the measurement of refractive index. Okay. Coming on to the next property, which is the moisture content. The solubility of water in oil, it is quite low, that is 0.0005 to 0.05%. However, moisture may be present in some crude oils up to 1%. So the water in oil is undesirable, and it can be separated by using a Dean-Stark method, which is used for the determination of moisture in oil. And there is another method which is for the sensitive cases, which is the Karl-Fischer test. Beanstalk method, it is an instrument where here we take our, it is a method determines measure moisture by distillation with an immiscible solvent. So immiscible solvents such as xylene or toluene. Toluene. So firstly, what we will do, we will take a mixture of toluene and water. Suppose we take 50 ml of toluene and 5 ml water, and we heat it in this, and the vapors comes off from here, and here water is used for circulation for the cooling in the condenser. Then the vapors from the toluene and water mixture, it goes up here and cools down, and it comes down from here. Some amount comes from here and some amount is given as reflux. Suppose after some times, after the complete combustion of this sample, we get suppose 4.59 ml of H2. So we can say that the amount of water, mean the efficiency of this machine, we can say it is 4.59, 4.9 by 5 into 100, which is basically suppose it is 97%. Okay. Now we can take a mixture of our crude oil, suppose 50 ml of our sample, then 50 ml of our toluene and 5 ml of water. Okay. Now this sample is heated. Okay. Now this mixture is heated. Suppose this sample consists of some amount of dissolved moisture. Okay. On distillation, suppose we get here 5.2 ml of water. Okay. Since this crude oil and toluene and water, they are not miscible. So the two phase formation will be there, toluene, crude oil, and then water will be there. Okay. Depending on the density. Suppose we got 5.2. Just a second. Give me a minute. Hello. हेलो मैनू क्लास चल रही है मैं करती हूँ ठीक है हेलो हेलो ओके सपोज here okay, suppose here we get a here we get 5.2 ml of oil, that is basically here we were getting 4.9, but here we are getting 5.2, so basically it is 0.3 ml water extra. Okay, so how to get how much amount of water is present in the kerosene? We will be multiplying it with the efficiency. Okay, so this is basically the amount of moisture present in our crude oil. Okay. Coming on to another property, which is the cetane number. It is a measurement of combustion quality of diesel. Basically, octane number was the combustion quality of cetane. That octane number. Here it is the combustion quality of diesel. Okay. So as we inject this diesel into our compression I mean compression ignition engine. So with the mixture with the air, it burns. But when we inject Injection, when we inject the diesel fuel into hot compressed air, there is a delay between the injection and ignition of the diesel in the hot air. This time period between start of injection and start of ignition, this is very undesirable. Okay, so if this delay period is unduly large, there will be accumulation of too much fuel in the cylinder. So what will happen? Suppose you inject some amount of diesel. It comes in contact with compressed air, hot compressed air, and it ignites. Further, if there is this huge delay in the injection and ignition, then second pass of diesel will be introduced, then which will also take time. Then third, likewise, there will be accumulation of too much fuel in the cylinder, which will eventually burn with an undue rapidity, which will eventually burn with lots of pressure, and it will create thrust on the cylinder wall. It will create pressure on the cylinder walls, and it will cause a diesel knock. Okay, so cetane number is actually a measure of diesel knock. Okay. The delay period is inherently connected with the type of hydrocarbon. So, the preferred order of decreasing ignition quality is the cetane number for N-paraffins are highest, then the olefins, naphthenes, isoparaffins, and aromatics. It is completely opposite of the octane number. This order is the reverse of the order for gasoline anti-knock quality, and the ignition quality of diesel is measured in standard engine. Similarly, similar to the octane number, the cetane number is measured. Okay, we take a sample and we compare it with the some reference fuels. We compare it with the some reference uh, mixtures. So here it is a scale of 0 to 100, where cetane has sorry. This is okay. Basically cetane has 100 uh, uh, value, and 0 value is for alpha methyl naphthalene. Okay. Okay. So we take a mixture of the cetane and alpha methyl naphthalene in different ratios, similarly as we took in the octane number. And what will happen that after some times, if we compare the ignition quality of our sample and our standard mixtures, the mixture which shows similar ignition properties with our sample, the volume ratio or the volume percentage of cetane present in that mixture, suppose it is a mixture of 20 80. Then cetane is 20%, so the cetane number is 20. Okay, for example. And N-paraffin and hexadecane of cetane is given 100 cetane number, and an aromatic alpha methyl naphthalene is given 0 cetane number. Okay, if the ignition quality of the given fuel matches with the 40-60 blend of cetane and alpha methylene naphthalene, it is assigned a cetane number of 40. Okay, the shorter the ignition delay period, the higher is the cetane number of the fuel. Cetane number is the index of ignition quality of a fuel. High cetane number fuel will facilitate easy starting of the compression engine, and particularly in cold weather. So basically, in older weathers, if the high cetane number fuel is required compared to the cetane number, as I told, the specification of gasoline and diesel, it varies from country to country. So in colder countries, cetane number will mean diesel fuel of higher cetane number is required. Okay, cetane number of diesel products rich in aromatics and isoparaffins may be improved by addition of alkyl nitrates and carbamates. So basically, these are the cetane enhancers. Coming on to aniline point, it is defined as the temperature at which a liquid just becomes completely miscible with the equal volume of aniline. Why so? This high aniline point is an indication of high suitability as a diesel fuel. Why? Because as I told as we have seen here, for diesel fuels, higher cetane number is of and paraffins. Okay, so paraffins, as you know, the light dissolve light. So paraffins will dissolve paraffins, and aromatics will dissolve aromatics. Whereas this aniline, it is aromatic in nature. So mixture, if this aniline, it is not soluble in diesel, we will require higher temperature for miscibility. As we know, if we increase the temperature, then miscibility can be achieved. Okay. So this aniline is aromatic, and if our diesel consists of higher and paraffins, then it won't be miscible with aniline. And we increase the temperature. At some point, at some higher temperature, we will see that there will be miscibility of this aniline in diesel fuel. Okay. So if our diesel fuel is good, it has more N paraffin, it will not be soluble in aniline. So it will require a much higher temperature for miscibility. So that will be the temperature, that will be the aniline point. So if a higher aniline point is there, then we can say that our diesel fuel has higher cetane number. Another term is the diesel index. It is basically a prediction for our cetane number. So aniline point of a diesel fuel is converted into an empirical diesel index, which is aniline point into API upon 100. Numerically, the diesel index is usually 3 times higher than the cetane number. So the diesel index basically gives us a idea about the cetane number of our diesel fuel. Okay. How to measure the aniline point? So the aniline point uh, covers the so here, mixture of crude oil, this test tube is there, a mixture of crude oil and aniline is taken, okay, which will form, basically it will form two phases, okay. Now it is heated, a thermometer is introduced into the mixture and a stirrer is introduced for the mixing, okay. And there is an outer thermometer also present which holds it, which consists of water for low boiling solvents, low boiling crude oils, mean lighter crude oils, and the and if they boil up to 50 degrees C, then water is taken in the outer test tube, and if it boils above 50 degrees, then glycerol is taken. Okay, heating is done, and at a temperature you will see that this two phases they form one phase by mixing. Okay, so that temperature is measured here, which is taken as aniline points. Okay. Specific volume of aniline and sample are placed in a test tube and mixed mechanically. The mixture is heated at a control rate until the two phases become miscible. The mixture is then cooled at a controlled temperature. Okay, sorry. Then this after heating, when the miscibility has occurred, then this hot mixture. Just a second. Okay. So after the miscibility, this mixture is allowed to cool, and the mixture is allowed to cool at a controlled rate, and the temperature at which the two phases separate at there will be a temperature when this when small haziness, the turbidity will start to occur. That is the temperature when these phases start to separate. So that is basically the aniline point. Okay. Now coming on to the foaming tendency of oil, which is basically the high surface tension contaminants in lubricants as well as the air entrained in the in-use oil creates bubble. So the foam generate means sometimes what happens is due to the presence of the high surface tension contaminants in the lubricants as well as some amount of air if it is entrained, if it is present into the lubricants, it start to form bubbles and foam. These foam generate incomplete oil films. Okay, when these lubricants they are used, they generate incomplete oil films, which causes low oil pressure and accelerate oil degradation, including additive depletion. Okay, the foam test measures the foaming tendency of a lubricant. The tendency of oil to foam can be serious problem in the cases of high speed gearing, high volume pumping, etc. Okay, how to measure the foaming test? This is the foaming test apparatus. In the two chambers, we have taken the crude oil, our lubricant oil, or crude oil, we can say the two portion of the samples are maintained in the diffuser at two prescribed pre-established temperature. Different temperatures are kept in the two different baths, that is the 24 degrees C in the first bath and 93.5 degrees C in the second bath. And the air is introduced in each of the chamber using a diffuser. Air is blown through the sample at a controlled and constant rate of 94 plus minus 5 milliliter per minute for 5 minutes and allowed to settle for a, and after that diffuser air is blown into it for 5 minutes, and after that it is allowed to stay settle for a period of 10 minutes. If the foam height and volume is measured at the end of the period, if the foam height decreases, then we can say that the foaming tendency is lesser of that crude oil. But if the foam stays in that same thickness without decreasing in the 10 minutes settling period, then we can say that the crude oil has high foaming tendency. Okay. Coming on to some of the properties of the bitumen. The first one is bitumen is basically the heavier residues given off from the atmospheric distillation column, such as from the atmospheric residue, then vacuum residue, and some other heavier residues as well. So basically, it is the penetration test. It is the basic test for determining the grade of bitumen. The test is an it is this bitumen is it is mainly used for simply it is used for the making of roads and cars, etc. In the construction of roads, etc. So this test is an indirect determination of high temperature viscosity and temperature stiffness. So this penetration test is mainly to determine the viscosity, to determine the viscosity and the stiffness of our bitumen sample. The penetration of bitumen material is its consistency expressed as the distance in tens of a million that a standard needle penetrates vertically into the specimen of the material under specified condition of temperature, load, and duration of loading. What happens is simply we take a bitumen sample, and from a standard needle, it falls and penetrates into the bitumen sample. And the the length of penetration of the needle gives us an idea about the viscosity and temperature, viscosity and stiffness of our bitumen sample. Okay. The penetration of an actual sample of bitumen in any grade should fall between lower and upper values. So these are the grades of bitumen. Basically, 40-50 is simply 40 mm to 50 mm or 60 mm to 80 mm. So the penetration should fall in between these two values, like from 40 mm to 50 mm. Okay. Penetration index of bitumen. The bitumen sample is melted. This is a penetrometer. The bitumen sample is melted and kept in this cup, and it is allowed to cool for 30 minutes. The penetration is measured with a penetrometer by means of a standard needle is applied to the sample under specified condition. The test apparatus consists of a right frame which holds the sample needle. This is the sample needle in a vertical position and allows to slide freely without friction. The dial gauge calibrated in millimeter measured the penetration. This dial gauge measures the penetration, and the fuel is carried out. The test is carried out at 25 degrees C with the total weight of the needle, spindle, and added weight being 100 grams. Sometimes this needle is 550 grams. This complete setup, needle and spindle, it is 50 grams. But if sometimes some additional weight is also introduced, depending on the stiffness of the bitumen sample. Okay. The needle is released for a period of 5 seconds. The needle is released and it penetrates, and the amount of the length of penetration of the needle is determined by this meter. Okay. Softening point of bitumen. The softening point is measured as the temperature at which a substance attains particular degree of softness under specified condition of test. The softening point is used in the designation of hard bitumens and oxidized bitumens. Hard bitumens are the natural bitumens which are produced from the crude oil, and the oxidized bitumen is this natural bitumen, it is oxidized in the presence of oxygen. It becomes more stiffer compared to the hard bitumen. A test for checking the consistency of bitumen is the ring and ball softening point test. Okay. The scope of this test is to provide a method for determining the consistency of semi-solid and bitumen material in which the sole or major constituent is either bitumen or pitch. So this is the ring and ball test. This test covers the determination of the softening point in the range of 30 to 157 degrees C using a ball and ring apparatus immersed in distilled water 30 or 50. Mean if the bitumen it consists of lighter cuts, then it is heated in water bath, and if it is consists of heavier cuts, it requires more heat than 80 degrees C, then it is heated in the glycerine bath. The apparatus is assembled with the rings, balls, centering guides, and the thermometer in position, and the beaker is filled with water to a depth of 102 degrees C, not less than 102 degrees C, and not more than 108 degrees C. Okay. The bitumen it is heated carefully in an oven on a hot plate until it has become sufficiently fluidy to pour. It should be in a fluid manner, in a fluid appearance to pour, and the ring should be filled with bitumen. Okay, so we will fill the ring with bitumen. This is this kind of this ring. It is filled with bitumen. Okay, and it is allowed to cool naturally for 30 minutes. And if it doesn't become solid by then for another 30 minutes, uh, cool it. Heat is applied to the beaker, preferably with a gas burner at at a rate of around like we will heat at this rate. This will be heated. This okay. As the temperature rises, the ball will begin to cause the bitumen in the as the temperature will rise, this bitumen will start melting, will start becoming soft. So there will be these rings will start sagging into the bitumen. Okay, the water temperature at the instant the bitumen touches the bottom plate, after sagging, this balls will come down to the this. Come down to this plate. Okay, at this point, when the balls completely fall down, the temperature of the water is taken. If the two temperatures differ more than 1 degree C, the test must be repeated using fresh samples. And if these two balls fall at different temperatures, like at temperatures where the difference of the temperature is more than 1 degree C, then we need to repeat this test again. Cone penetration test of petroleum wax. The hardness of the petroleum wax is expressed using this cone penetration method. So the low penetration value indicates a hard wax, and the higher penetration value indicates softer wax. So the a molten wax is taken. The sample is molten in an oven at 82 plus minus 2 degrees C in a standard container. This wax is molten, and then it is poured into this container, and then it is cooled at room temperature cooled to room temperature. The cone from the penetrometer, it is released, and it is held for 5 degrees C. Okay. It is released and it is kept there for 5 seconds, and the total penetration from the scale is read for 3 times. And this test is repeated 3 times to get an average. Okay, which will give us an idea about the hardness of the petroleum wax. Grease penetration test is also done in the similar manner. The penetration test begins with the grease at room temperature being leveled up in a cup. Using a penetrometer, cone is dropped into the cup for 5 seconds, creating a hole in the grease. And the hole depth in the tenths of a millimeter is measured, which is known as the unworked penetration or P naught. Unworked penetration means here that the grease, which is still not used practically or in any application, firstly, the penetration for that is done, which is unworked grease. Further, this grease is then sheared using a mechanical hand operation device through a 60 double strokes. Like this, if we suppose we stroke it like this for 60 times, then we can assume this grease as worked or applied in some work or in some application. Then again, this test is done, which gives us a P60 value, which is the worked penetration. Okay. Now, two other tests which gives us an idea about the corrosion test. Corrosion of the corrosion of the Corrosion mean corrosivity of hydrocarbon liquids. Basically, the copper strip corrosion test the it measures the sulfur corrosivity of the hydrocarbon liquid. Basically, the sulfur content present in the hydrocarbon, it causes the corrosion in different storage tanks or in engines or burners, etc. Okay. It is subjective test based on the discoloration or and corrosion of a copper strip under standard test condition when compared to a series of ASTM standards. So basically, a copper strip is taken and it is immersed into the crude oil where, due to the presence of sulfur content, corrosion takes place. It is immersed into the crude oil for 3 hours at a temperature of 550 to 100 degrees C. And it is kept there for 3 hours. And after that, the elemental sulfur and reactive sulfur species such as hydrogen sulfide and mercaptans in the liquid hydrocarbon will react with the copper strip and cause the product to fail the test. And after that strip is taken out and it is compared with this strip, this standard strip, the corrosion strip, copper strip corrosion standard, and the color of the copper strip is compared with the color on these strips, giving us an idea about the corrosion of the sulfur corrosivity of the crude oil. Okay. This silver strip corrosion test. This corrosion test is for aviation gasoline, then ATF, normal gasoline, and fuel oil, lubricating oil. Another test is the silver strip corrosion test, which is mainly for the aviation turbine fuels towards silver. Similarly, a polished silver strip is immersed into the fuel at an elevated temperature. It is kept there for some time, and after a specified test period, the strip is removed from the sample, washed, and evaluated for corrosion. It is compared with these colors, matched with these strip colors to determine the amount of corrosion that an aviation turbine fuel will cause to an silver strip. Okay. Now coming to the assignment questions. The first question is find out the wrong statement. Viscosity is an important property of petroleum fuels for. We have to tell the wrong statement. So here the first statement is the transportation through pipelines. Yes, it is not wrong. It is correct. Viscosity is an important characteristic for the transportation through pipelines. The atomization is a burner. Yes, atomization in the burner also is affected by the viscosity of a petroleum fuel, and the measuring the resistance of fuel. Yes, it is the definition of viscosity which is it tells about the resistance to the flow of the crude oil. Determining the burning quality of fuel. No, it doesn't determine the burning quality of the fuel. So this is the correct answer, which is the wrong statement. Okay. Coming on to the second question, which is the initial boiling point of petroleum fuel measured by the ASTM method is the temperature at which, as I told, it is the first condensed drop collected. The first drop of the first drop which is collected from the condenser, it gives us the initial boiling point of the petroleum fuel, as I told in the distillation range of the petroleum fuel topic. Okay. The full form of ASTM, it is the American Society for Testing and Materials. Okay, the full form is American Society for Testing and Materials. The fourth question is the knocking of gasoline engine means. The knocking, it means the creation of the power waves due to the burning of a rapid burning of large amount of gasoline fuel inside the engine. So basically it is the formation of pressure waves due to rapid burning of the fuel in the cylinder. Okay. Which statement is correct? The motor octane number is determined for the fuel under load. As I told, motor octane number, it is determined for the fuel under load. Find out the wrong statement. Water content in petroleum product is measured by Dean and Stark. Water content is not measured. Moisture content is measured, as I told. Okay. Viscosity is measured by Redwood apparatus. We have to get the wrong statement. Water content, moisture content, similar thing. Viscosity is measured by Redwood apparatus. Yes, Redwood apparatus, it is a kind of viscometer. High and lean point of a fuel is an indication of high suitability of diesel oil. Yes, this is correct. If there is high aniline point, that means higher temperature is required for the miscibility of aniline, equal volume of aniline and crude oil. Okay. Diesel index is the measure of viscosity of diesel. This is not correct. It is not the measure of viscosity of diesel. So this statement is wrong. Okay. So this is the answer. The preferred order of decreasing octane number is, as I told, aromatics show better octane number and N-paraffin show bad octane number. So the option is aromatics greater than isoparaffins, naphthenes, then greater than naphthenes, and greater than olefins, and greater than N-paraffins. Okay. Coming on to the next question, which is foaming tendency of a lubricating oil is determined to know the tendency of the oil to generate incomplete lubricating oil films. Okay. If foaming tendency is there, it will form incomplete lubricating oil films and will not form uniform layer of the lubricating oil on the moving parts of the engine of the machine. Okay. Penetration index of bitumen is a measure of the high temperature viscosity and low temperature stiffness. As I told, it is a measure of the viscosity and stiffness of the bitumen. Okay. The next question is gum is produced in gasoline product by it is basically the reaction of oxygen of air and the olefin content of gasoline. Okay. Olefins and diolefins basically it reacts with oxygen to form resinous polymer substance, polymer gums. Okay. So this is for today session and thank you for your patience. We are done for today's session. Thank you everyone.